So next question I have here is for 2015, and it is question 9. So A, define acid according to Arrhenius, substance that dissociates in water to produce H plus ions. Bronsted and Lowry, acid is a proton donor. Define pH, minus log to the base 10 over H plus ion concentration in moles per litre. And state one limitation of our pH scale. So you have a list of 3 or 4 there. Only accurate for dilute solutions, only valid or useful in a 0 to 14 range, only applies to aqueous solutions. Any one of those will get you your marks. Next then, we're asked to graph the pH curve for the titration. Okay, so if I look at what I have here, so again you have to use graph paper, and I am going to have 0 all the way across to 40. Okay. And my pH then goes up to 12.4. So again, I'm just going to draw my y-axis here. Okay, so my y-axis is going to be my pH, and my x-axis is the volume of NaOH added, and that's in centimeters cubed. Okay, so pH, I'm going up to 12.4, so 1, 2, 3, 4, 5, 6, 9, 10, 11, 12. So I can go up in ones. Obviously, if you can't go up in ones, you go up in twos. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so that's my y-axis. And then my volume of NaOH, so I think I'll go across in 4s there, if I can. 4, 8, 12, 16, 20, 8, 32, 36, 40. Yeah. So again, doesn't really matter what you yourself decide to, but you have to go across in equal multiples. So 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. And all I'm going to do now is I'm just going to write and correspond each of my values here with my table. So with 0 centimeters cubed, I have a pH of 3.3, so that's my first point. Then at 2, I'm up to 4.1. At 5, so 6 halfway then is 5, I'm up at 4.5. Then at 10, I am up at 4.8. Okay, so I know now it's probably hard for you to see the bulk here. So that's at 10, I'm at 4.8. So at 15, I'm at 5.1. So that's 14, so halfway again. So 15, I'm at 5.1. At 17.5, so that's 18, so 17.5, I'm at 5.6. Okay, at 19 then, I am at 6.2. At 19.5, I'm at 6.6. At 19.8, I'm at 7. At 20, I'm at 8.9. Okay. At 20.2, I'm at 10.7. Okay, at 20.5, I'm at 11.1. At 22, I'm at 11.6. at 25.5. I'm at 12.1. At 30, I'm at 12.3. And finally then at 40, I am at 12.4. Okay, so that's what you're drawing there. So we're going to just draw now the curve. Okay, so just draw a freehand line here through my points. Okay, so you'd have 3 marks there for labelling your axes, 3 marks for working out your scales, 3 marks then for your smooth curve, and then 6 marks for your careful plotting of this. So quite a nice allocation of marks there. Then you're asked, part D, to calculate the initial concentration of ethanoic acid in the beaker. Okay, so firstly I'm given my Ka, which is 1.8 by 10 to the minus 5. Now, if I look here, I'm told my initial pH is 3.3. Okay, so from that I can work out my amount of H plus ions that I have in this solution. So H plus is equal to pH equals minus log to the base 10 of my H plus ion concentration. So my H plus ion concentration is going to be the anti-log of my pH minus 3.3. So my concentration of H plus ions at the start is 5.012 by 10 to the minus, and it's 1, 2, 3, 4. Okay, so now what I have is H plus equals the square root of Ka by Ma, and remember it's this that I'm looking for, my concentration at the start. So 5.012 by 10 to the minus 4 equals the square root, I'm given 1.8 by 10 to the minus 5 in the question, multiplied by Ma. What do? I square both sides. Okay, so that's going to give me 2.51 by 10 to the minus, and it's 1, 2, 3, 4, 5, 6, 7 equals, and that's going to give me 1.8 by 10 to the minus 5 by Ma. So my Ma then is both sides divided by 1.8 by 10 to the minus 5, and that's going to give me 0.0139. So that is my concentration of my solution at the start. Make use of your graph to deduce the volume of sodium hydroxide solution required for neutralization. So if I look at my graph here, the amount that's used to determine my neutralization is where my steep vertical rise is. So if I look down, my volume of NaOH added is 20 centimeters cubed. Okay, so that's your answer there. Always you read from the vertical region what value that coincides with to your volume of NaOH, 20 centimeters cubed. For part E then, what indicator? Okay, so again here sodium hydroxide versus ethanoic acid, strong base, weak acid, so phenolphthalein. And final part then is refer to your pH curve to justify your answer. And again here, colour change of indicator coincides with vertical part of the graph. And that is 2015 question 9.